I'm here to talk to you today about driving new technology in large, possibly change-averse organizations. So if you work for a startup, this talk is not for you. My name is Ryan Kirk. I work for a company called Cheetah Digital. This company is actually not so large, so all the negative things I'm going to say right now doesn't actually apply to my current employer. But I have worked for a large company in the past, here in Charlotte and elsewhere, and a lot of us local people here to Charlotte do work for, a big bank or a larger financial institution. And it may sometimes feel like trying to change direction or trying to adopt a new technology is like trying to steer the Titanic. Now, it actually is possible. It was possible, actually, to steer the Titanic. It just wasn't easy to change course very fast. I'm going to go on a tangent here for a little bit. Back when the Titanic was in commission in 1912, this was during this transition period from tall sailing ships to steamships. And on a sailboat, what you have is a tiller and a rudder. It's very simple. The tiller is a lever that you turn, either port or starboard, and it turns the rudder the opposite way. So if you're steering a sailboat and you want to turn starboard, which is to the right, you're going to turn the rudder to port, which is the left, and the rudder will turn starboard to the right, and then the ship will turn starboard to the right. So basically, on a sailing ship, you're turning the tiller the opposite direction that you want the ship to turn. Now, when they started building these steamboats and they're larger, you can't run a tiller all the way from the back, to wherever the helmsman is. They put in these wheels, right? So now this wheel is not just connected to a simple lever, which is the tiller. It's connected to some pulleys and a winch. And, intuitively, these engineers thought, hey, let's make it so that when you turn it to the right, the ship actually goes to the right. So again, when you're turning the wheel to starboard, then forget what the tiller does because there's all kinds of mechanics in the middle. But what you care about is what the rudder does, right? You want the rudder to go starboard, and then the ship will go starboard. Turn the wheel port, the rudder goes port, the ship goes port. So there was this transition period when these helmsmen were used to doing the opposite, and now they had to do the same as what they wanted, right? Kind of like when Apple switched the scrolling mechanism on the MacBook to be consistent with the iPhone, and everybody was up in arms, right? We're scrolling opposite now. But now everybody feels it makes sense and it's intuitive and it's consistent. So what they had was called tiller orders and rudder orders. And the tiller orders would say hard to port or hard to starboard. And they would turn the tiller to the starboard, but again, the rudder would go the opposite direction. So they were calling out the opposite direction that they wanted to go because they wanted to keep it simple for the helmsman to turn the tiller to the right direction, to the correct direction. So when the Titanic set sail, not sail, but set steam or whatever, I don't know what you say about that, they were still using tiller orders, but on a ship with a complicated rudder system. So when they saw the iceberg, they knew which way to go. He said hard to starboard. He meant, turn port. And the helmsman thinking he's trying to go opposite, right? But then so is the other guy, they're trying to go opposite. And so they just did the wrong thing. They just mixed up. And that was one of many mistakes with the Titanic, but that was the very first one. So basically, now taking this whole metaphor analogy and modernizing it a little bit, they were using an outdated naming convention, out of tradition, because they didn't want to change the way they were doing things, even though technology had advanced and their naming convention didn't make any sense with updated technology. So their inability to adapt is, again, the first mistake that sunk the Titanic. So that's important to think about when we're thinking about technology, right? If we're always doing the same thing we've done before, or thinking in the paradigms that we thought before, that can go really badly. All right, so let's say you discover some shiny new piece of technology that you really like. Now, this is a stand-in for whatever your thing is right now, right? It could be GitLab or Kubernetes or Artifactory. It doesn't matter, right? Think about your thing right now. But let's talk in generalities, right? Say it's modern. Maybe it's easy to learn and use. It's modular. It has good documentation, a good API or CLI or GUI or whatever it is that you need. Helps you solve problems, maybe helps you automate things. So you've discovered this new tool or piece of technology, and you want to try using it at your company, maybe for an upcoming project. So you're really excited about this, right? But how do you get it in? How do you use it? Again, you're not at a startup here. You can use whatever you want at a startup. At a large company, such as a bank, you have standards, you have rules, you have hundreds, if not thousands, of people using processes and workflows. You can't just throw up a GitLab and expect that to go well. So that's what we're going to go over here. So anyway, in your mind now, pick out your technology that you got, and we're going to talk about that. You might think to yourself, this technology is so awesome, it will sell itself. I'll be able to use this. I'll be able to implement this. My example is PHP. That's just a joke, obviously. For me, that was actually Ansible. When I discovered Ansible, I'm like, this is the best thing. Like, everybody's going to use it. And actually, it was right. It just took a few years for everyone to catch up to my great vision. But the truth is, the reality is, nothing sells itself. Did you know that beer salesmen actually exist? And not just beer salesmen to sell, like, crappy beer. Beer salesmen exist to sell the very best beer. So not even the very best things can sell themselves. If you need your technology and you want to use it, you got to get it in front of people. People need to understand how it solves their problems. How does it make their lives easier? How to use it, why they need it. You have to sell it. So as engineers, this is definitely outside of our comfort zone, right? This is a engineers or nerds guide to kind of navigating the waters of how are we going to introduce this. But again, if you don't want to create something that's going to get abandoned in a year or 2 years after you move on, and you want this to have some long-term viability, then we're going to need to take certain steps. We're going to need buy-in. So I'm going to describe to you 3 avenues that we can go down for getting your new tech into production. The first one is called it's just a formal project process. This is by far the most boring method. The second one is a skunkworks project, which I will explain, and the third is a sideload install, which I will also explain. All right, so let's before we get into that though, let's talk about some of our obstacles. There's a lot of things that we need to be aware of in our landscape. First of all, there's the inertia of that ship, which direction it's going. There's going to be a lot of gates and gatekeepers. You're going to have, people having turf wars and wanting to own certain technology, architectural review committees, silos, different people using different tools, doing different things that are not standardized. Obviously, some possibly budgetary concerns. So you need to be aware of all these things in your company. And these are things that are going to help you decide which route to go on. I can't tell you which path to choose. I'm going to give you some guidelines, again, based on those 3 different options. But these factors will help determine that. All right, so let's talk about a formal project. So we're taking our technology, say it's GitLab, and we're turning it into a project. And this is the boring method. But again, if you do a bunch of this prep work, we're really going to increase our likelihood of getting this project approved. So realistically, if this is something such as hardware or software that requires licensing, you're going to have to pay for it. Unless you have your own budget and you need to get approval for it, you're going to have to go down this path because you need to request approval. So the very first thing you do is get a trial license and test out your thing, set up a proof of concept, and figure out if it works for you first. Right? This is step 1. Now, assuming it works, we're going to start collecting information to help us make our case for for this technology, and now we're substituting the word technology. We're substituting the word project for technology. Now it's a project. That's what they want to hear, right? And we need to fit it in the paradigm of business concerns. So this project needs to be a solution for an existing problem that we have as a business. And this is legit. I'm not saying make anything up. I mean, you really should be solving a problem that exists. Otherwise, you're kind of just playing, and that's fun and everything, but that's not your job, right? Unless that is your job, which, please, can I have your job? Anyway, so for example, if we're having outages and we're breaching SLAs, is this, how much is that costing our business, right? Or are we losing leads? Or are we being inefficient? Or, are we spending too many man hours doing something manually? Or do we have too many mistakes in a certain process? Or are we standardizing multiple, departments and teams? So all of these are things that are kind of typical problems that we can kind of, latch on to as our technology is addressing as a solution. So we're gonna figure out, the impact of that problem. Again, some of this stuff, this is information you may not have. You need to talk to other people. But we're gonna figure out the impact of the problem. We're gonna figure out how much that problem costs us. And then we're gonna figure out how much our project costs the company, because we're gonna determine the level of effort, the time it takes, and then how much it costs, CapEx and OpEx. It's either all just preliminary stuff. We just want to do our homework so that we can get this proposed as a project. And by the way, when you estimate your level of effort, multiply it times 4. Scientifically proven, we are way too darn optimistic. We just overestimate our capabilities. So protect yourself. All right? Now, I've written some really great Python code up here, as you can see. But this is the basics behind creating a business case. If the cost of the project is less than the cost of the problem that you are addressing with that, or the impact of that, right? Like the business loss, the penalties for breaching your SLA, or the leads that you lost because the site was too slow. Whatever that is, if your project costs less, then you have a business case, right? So this is how we're transforming our technological need into something that makes sense for the MBA types and the PM types. So what we're going to do, we're going to write it all up in a project proposal. We're going to, again, kind of use some weasel words because we don't know for sure, but we want to propose it. We want to get it on the timeline, include all the estimates, and show that it can save money. All right. Now, I'm going to pause. Before we go any further, you need to make sure that you have the bandwidth for this project. Don't do this if you can't own it. You need to be able to champion it, implement it. You're starting out, right? So you're going to be supporting it. You need to be able to write documentation, eventually maybe run training, handover, or some kind of onboarding for whoever else is going to support it, so that you can move on to the next new shiny piece of technology. If you want this to be, again, not abandonware in your company, which hopefully you do care about that, then you need to make sure that you have the capacity for all this. And if you don't, it'll fail, so just stop. You can't go it alone, right? So the other thing is you need sponsors and allies. So we're going to find people who are going to benefit from this, who may end up supporting it. You're going to find, people who are going to be allies in this project proposal. And you're going to talk to them, reach out to them. Don't send an email, just have a conversation, make sure they're on board with it, and get that buy-in, right? So now that we have our whole, project parameters and the proposal, the buy-in, we're going to submit it. Now, again, every company is different, but if you're familiar with your company, there's some kind of PM group or technology onboarding team where you can propose this to. Maybe it's your manager. Write it all up. Be honest, right? It may not work. There could be some pitfalls. Don't sugarcoat it or lie. That's going to backfire. And then you also, you don't want to sell it as a panacea, because we all know, everybody knows nothing is a panacea for everything. And then second of all, you want to identify the ownership because you want to present that in terms of reducing risk. They love to hear that kind of stuff. You're reducing risk because you've identified long-term ownership. All right, finally we're done with that one. So we got the boring one out of the way. It has to be done sometimes, and you need to be able to navigate that process, even though you just may want to put your head down and code. You need if you want that budget, that may be what you need to do. So the second method is basically running a skunkworks project. Now, the skunkworks it still is a division of Lockheed Martin that was set up, I believe in the 50s actually, as a minimally supervised, low overhead, low supervision, low bureaucracy, small team of engineers to design the U-2. That wasn't the first plane they did, but that was kind of the first really cool airplane they designed. High altitude spy plane. We flew over the Soviet Union, and it was a big deal. Right, so they had a lot of success with that. So then they designed the SR-71, and that was successful as well. And then they did the stealth fighter, and the F-22, and the F-35, and the stealth ship, and one of the first drones, and probably a whole bunch of other stuff that we don't know about. Anyway, the point is, you can get some really talented, dedicated people and give them a little bit of freedom and flexibility, and they can come up with some great stuff. Side note, I was the nerd in high school in the late 90s that created a site all about the skunkworks. As you can see, I won some rather prestigious awards from GeoCities at the time. This is taken from the Wayback Machine in '98, so, I was pretty good for my day. Scarily enough, I just took this screenshot 2 nights ago from an incognito browser window. Someone at NASA, the #1 hit is still a bibliographical reference to my site that's been offline for like 15 years because it was taken down due to copyright violation. So NASA, if you're watching this, please take this down. It should not. Nobody should be referencing my high school GeoCities page on your site. I mean, we want to go to the moon, so you don't want me to be associated with that. Anyway, so moving on. Skunkworks projects can be a little dangerous, right? You don't want to run afoul of the rules. You don't want to be doing something in secret. You want to have your manager on board. But you also want to use, you're also going to have to use open source software or something you already have, right? Because this is like a non-budgetary thing. You're going to do it in your spare time or your project time. Google used to they used to be famous for having the 10% side project time. And that's kind of gone away over the years, but there's some great things came out of that, most notably Gmail. So you can always use that as an example of, hey, I've got this great idea, let's try it out. It may or may not work. Get your manager on board and spend some time on it. Don't miss don't be derelict in your other duties, but it could work. And if it does, start testing it slowly, right? You don't want to announce, hey, version 0.1 of Ryan's widget is available, and we have an undeclared, undefined variable, and it doesn't even run. So we're gonna test it very quietly and very, very slowly and iterate, right? We can flesh it out. We can do that because it's just us, and there's no PMs and hope other parties that are doing it. Story time. One of my coworkers. You guys don't get that one? Come on. You guys should have watched Vine a little more when that was around. One of my coworkers at a previous company discovered graphite and Grafana, and he built out this really great infrastructure. He left, and I inherited it. And, it was just internal to our team. We were just figuring it out at the time. And so I was working out some of the bugs. We had multiple data centers and trying to get all the data through, message queues into the right place. It took a little bit of working out. But over time, I figured it all out, kind of got it streamlined. Never advertised this to anyone, but at one point, I was able to use the data in Graphite to solve a production issue. It was a P1, or maybe it was a P2. I solved at least a couple of P2s and a P1. So all of a sudden, this was showing value to other people in the ops group. And suddenly it became a de facto standard, right? It was adopted. So now I really had to support it, right? So this is why you want to work out the bugs and this kind of thing beforehand, because now that everybody's relying on it, you need to kind of support that uptime. So that's an example of a Skunkworks project, a side project that was successful. And the unsuccessful ones, just don't tell anyone about them. All right, so the third method I'm going to talk about is the sideload install. Obviously, here I'm referencing method of installing an app on your phone without going through the official app store. Most of you are probably familiar with this term, but basically, if you're not, there's a way to install apps on both Android and iPhone that bypass the official app store, and you kind of just do it yourself at your own risk, right? You could contain malware. It could be a spy app for Google or Facebook. If you've been following the news, it's exactly what happened recently. So let's talk about the sideload install method of getting your technology into your company. Now this is, if you can swing it, this is by far the easiest method because you're going to tack it on to another existing official project. So what you're going to want to do is find dependencies. Look for things like upgrades that may require a change in methodology or change in technology or a new technology. So let me give you two examples from my personal experience. At one place, I had a project to roll out Ansible Tower. At this company, the standard for version control was Subversion, SVN. If you could believe it, Git was not allowed to be used. So again, think big banks here, right? This is how it works. Well, we pretty quickly determined that we required a pull request-based workflow in Git for this project to get our code into Tower, having gone through all the appropriate checks, and not just be pushing random things into production. So we decided that we can't do this with SVN. We need to use it with Git. So we were able to incorporate adding Git to the technology standard as part of this project. And in fact, ended up implementing Bitbucket as part of that project. So the whole Git workflow, setting up all the ACL, that was great. I was able to introduce Git, which to be honest, I was secretly using unofficially. But now it was official, right? We're pushing out with this project, and everybody can use it. People can commit, and we're not circumventing the rules. Another example, recently on my current job, we've been provisioning our long-running stateful servers using Foreman. These are the ones that stick around and are puppetized. So when we started building out our Kubernetes clusters, we started looking at it and you thinking that is probably not the right technology. We want to look at Terraform for that instead. And so we found it was the right tool, as probably most of you would agree. And so we included using Terraform now in the Kubernetes project, and actually Prometheus as well. So now we're two technologies that me and my guys really wanted to play with, that we would have had to kind of do on the side or Skunkworks. Now are officially part of this project scope, and we can implement them. So the siloed install method can be really useful if you can make it happen, especially if you have a PMO group and you kind of go through this normal project process at your company. That's the siloed. So those are the three methods: formal project process, Skunkworks, and the siloed install. Now, all of these methods are going to require significant effort on your part. None of them is easy. Technology is not easy. Based on all those potential obstacles, remember we looked at the beginning, these are things that you need to be aware of. And you need to be smart and introduce your technology with the correct approach based on those issues. But if you do, you can turn that rudder the right direction. So I'm going to leave you with an XKCD. It's quite appropriate. The simple answer to questions that get asked about every new technology. Will it make us all geniuses? No. Will it make us all morons? No. Will it destroy whole industries? Yes. Will it make us more empathetic? No. Will it make us less caring? No. Will teens use it for sex? Yes. I mean, look, if they're using Artifactory for that, maybe we should talk to them so we can learn something. Just kidding. Were they going to do it anyway? Yes, let's move on from that. Will it destroy? I think that he's talking about Snapchat here, right? So slightly different. Is it going to destroy music? No. Is it going to destroy art? No. But can't we go back to a time when, no, this is extremely applicable. Look, is anyone in this room nostalgic for the days of corn shell scripts and tape drives? Yes, Kubernetes is hard, but wouldn't you still prefer it over an AIX cluster? Will it bring about world peace? No. Will Kubernetes cause widespread alienation by creating a world of empty experiences? And I would add to that, abstracted by API layers. Yes, we were already alienated. This was actually recently addressed. So this alienation of us humans from each other by technology was addressed. kubectl get unity. Unfortunately, it just installs a really ugly Ubuntu desktop on your environment on your laptop, so that pull request was rejected. Anyway, that's it. Thank you very much, and hope you have a great day.